What if your internet wasn't just a service you trust, but one you could actually prove? Today, we're doing a deep dive into the 4 cryptographic proofs that are the absolute bedrock of the Dawn network, a project that's trying to build exactly that. So, let's get into it. It all boils down to this one really fundamental question. For as long as we've had the internet, you've just had to take your provider's word for it. But what if you didn't have to? What if you could mathematically prove the performance second by second? And that's really the core idea here. It's a huge philosophical shift. We're moving away from the old trust me model, where the speed is just a number on an advertisement, to a brand new prove it model, where every single part of the network is being constantly verified. Okay, so how do you actually prove it? Let's start with the one thing every internet provider promises: speed. This is where Dawn's very first proof comes into the picture. I mean, think about it. When you run a speed test, you're really just getting a tiny snapshot in time. How can an entire network guarantee its performance all the time? How do you know a node's true capacity without just, trusting the person who set it up? Well, the answer is something called proof of backhaul. Now, this isn't some one-off test you run in your browser. It's a continuous, decentralized system where a whole pool of challenger nodes are constantly stress testing the network. They're measuring everything: real-world speed, latency, jitter. It's basically a nonstop, real-world audit of the entire network's health. And this just shows you how much more efficient a decentralized system can be. Because Dawn's testing is so dynamic and spread out, it can figure out the network's true connectivity about 30% faster than the old static methods. That's a huge deal. So how is this actually verified? Well, you're going to need a dedicated desktop app. See, a simple browser extension can only do a simple ping to see if a server is online. But to really test the capacity, the network has to blast a high volume of data through. The desktop app uses something called UDP connections, which is a protocol built for speed, to properly stress test a node and prove what it can really handle. Okay, so speed is verified. Check. But when you're building a physical network, there's another absolutely critical piece of the puzzle. You have to make sure the hardware is actually where it says it is. Right, this is a classic problem for any decentralized physical network. If somebody could just fake a node's location, they could create all these ghost nodes to unfairly grab rewards or just mess with the whole network. This is called a Sybil attack, and you need a super robust way to stop it. And this is solved by proof of location. It's this really sophisticated 2-layer system that's designed to cryptographically pin a node to a specific spot on the map. The system has 2 parts. For the nodes that are plugged in with wires, it uses what's called latency triangulation. Basically, by timing how long data takes to travel from a few known points, it can pinpoint the node's location. Then, for the wireless nodes, it uses radio-based triangulation, which is kind of similar to how GPS works. It's a really smart, 2-pronged approach for the 2 different kinds of hardware. And to make this even more bulletproof, Dawn uses a special hardware technology called TPOT. This gives every single device a unique, unchangeable fingerprint, making it incredibly hard to clone or fake. It's like adding a physical, unpickable lock to the digital proof. So, we've proven speed and we've proven location. Now we get to the economic engine that actually makes the whole network run, managing resources and making sure everybody gets paid correctly. The last 2 proofs make up this economic layer. First up, you've got proof of frequency, which is all about managing the wireless spectrum, and it does that through staking. Then there's proof of service, which handles all the billing and payments. It uses data metering to act like a totally automated accounting department. Let's look at each one real quick. Proof of frequency is pretty darn clever. To even use a wireless channel, a node has to stake tokens as collateral. Then its neighbors are constantly checking to make sure it's not causing any interference. On top of that, nodes get rewarded for solving these little geographic puzzles, which helps build this trustless map of the whole wireless environment. And then proof of service is the final piece. It takes all that usage data, matches it up between providers and users, and then automatically settles all the payments using smart contracts on the Solana blockchain. No more invoices, no billing department, just instant, automated, trustless transactions. So we've got these 4 really powerful proofs. But this brings up one last and maybe the most important question: who's verifying the verifiers? How do we know the data from all these proofs is actually accurate and nobody's messing with it? Well, that is the job of the witness chain. Think of it like a network of independent, decentralized referees. or watchtowers. Their only job is to validate all the data coming in from those four proofs before it can be used by the network's smart contracts.
Here's how it works, and this is the really cool part. The witness chain is actually secured by Ethereum, basically borrowing its massive economic security. These watchtower nodes act as this super trusted validation layer. They take all the raw data from the network, check it, and only then do they pass that clean, trustworthy data over to Dawn's fast and efficient smart contracts on Solana. It's genius. You get the best of both worlds, Ethereum's insane security and Solana's incredible speed.
And when you put it all together, the four proofs, the verification layer, you get this: a complete shift away from just having to trust your provider to an ecosystem where performance, location, and payment are all mathematically proven and verifiable. And that leaves us with a really fascinating final thought. We've just seen how an entire network can be built on verifiable proof instead of just blind trust. So, if we can do this for something as complex as the internet, what else in our digital lives is long overdue for a prove-it model?